Okay, so let's talk about something that uses Yarn in a novel way to actually make things faster on your cluster. That's Apache Tez. What Tez does is it manages what we call directed acyclic graphs, kind of like Spark does. We talked about that a little bit back then. What is Tez? Well, first of all, it has one of the coolest logos I've seen in the Apache world. I love that little like angry bull charging at you. And the idea here is that you have the elephant obviously represents Hadoop, and it's going really fast. So that's what Tez is all about. It's about accelerating your jobs that run on your Hadoop cluster. And it's kind of seamless. It's under the hood, so you don't really have to think about it very much, but it's good to appreciate that it's there and to make sure that you are using it when you can. So all it really does is it makes your Hive, Pig, or MapReduce jobs a lot faster than they would be normally. It's basically an alternative to MapReduce for these higher level applications to run on top of. So when you have a Hive or a Pig job, you can configure them to not use MapReduce as their underlying technology for managing the resources and jobs and tasks that you need to execute to actually get the answer you want. Instead, Tez can take MapReduce's place, and it can be a lot more efficient. So Tez is fundamentally an application framework that clients like Hive and Pig can code against as a replacement for MapReduce. And you can even have MapReduce jobs that don't use MapReduce, counterintuitively enough, but use Tez instead. That's also possible to do. The secret to its success is it constructs directed acyclic graphs. So that's the same secret behind Spark's success, or part of the secret anyway. Spark's also doing a lot of stuff in memory, which is a lot of its advantage too. But by constructing these DAGs, it can complete your jobs more efficiently. So instead of having all these MapReduce jobs that depend on each other and run sequentially, since Tez has a more holistic view of what you're trying to do, it can sometimes eliminate unnecessary steps or run different parts of different steps in parallel and try to minimize dependencies that don't need to be there. It also optimizes the physical data flow on your cluster to make sure you're not moving data around that doesn't need to be moved, and it optimizes the resource usage of your cluster as well. And how it does it is kind of magic, but here's one concrete example that keeps showing up on Tez's documentation. This is straight from the Tez website, by the way, tez.apache.org. And here's an example of a real case study of a Pig or Hive job that runs on MapReduce, and you can see how it consists of various MapReduce stages. So we have sort of a mapper and a reducer, which feeds into another mapper and reducer, and another mapper and a reducer over here, and they all get combined together across HDFS. That's what these clouds represent, to a final mapper and reducer that gives our final result. But after Tez takes a look at this, it might do something more efficient. It might say, hey, I don't need some of these stages. I can maybe combine them together or run them at the same time. So with Tez, it might take these 4 distinct MapReduce stages and just run them all together as this one sequence of dependencies, where we just start off with a mapper and a reducer and a mapper and a reducer, and maybe those go straight to a reducer and these both go straight to a reducer and skip some intermediate steps. So by skipping all those steps and not having to go out to the HDFS cloud as often, it can be a lot faster. Where does Tez sit architecturally? This is copied over from the previous lecture on Yarn, just a reminder here. So remember, Yarn is the resource negotiator. That's part of Hadoop 2. That sits on top of your HDFS storage layer. And on top of Yarn, various applications can be built, such as MapReduce, or Spark, or in this case, Tez. So Tez, as you can see, is at the same level as MapReduce. And when you have things on top of this layer, like Hive and Pig, they can talk to MapReduce or Tez to actually get the results they want. Spark's kind of its own thing. It can basically do everything that Pig and Hive can do anyway. So that's where Tez sits architecturally. And as a user, there's not a whole lot you have to think about. All you have to do is make sure that Hive or Pig is actually using it if you're using Hive or Pig. And odds are it probably does by default anyway when your cluster was set up. With our Hortonworks sandbox environment, Tez is pre-installed and it is the default for Hive, so there's nothing you really need to do. It just makes things a lot faster. And here's a chart that I lifted from a presentation that the Tez folks did that makes that quantifiable. You can see this is query times, and obviously lower is faster, and faster is better. And the blue bars are how long a query took using MapReduce, and the red bars are how long it took using Tez for the same exact jobs. So you can see it pretty consistently outperforms MapReduce by a very large margin. It's very exciting stuff. I mean, these guys seriously should be proud of what they've done. So let's make it real. We've got a Hive query. We're just going to do the same thing that we did back when we were teaching you Hive, but let's run it twice, once using MapReduce and once using Tez, and see just how much faster Tez really is. And also, while we're at it, we'll learn how to configure Hive using Ambari to use one or the other. So let's go dive in and try it out.